What's up guys, and welcome to this video. This is another concept video on projectile motion. And it's projectile motion in 1D, so in one direction basically. Okay, so we know that the Earth attracts objects near its surface. Okay, so we know that if we're standing on Earth and we're a nice human, if we jump up, we're going to get attracted downwards due to gravity. There's a weight force acting. And if there's no force opposing it, such as air resistance or friction, then the object will accelerate towards the Earth. And this is what we call free fall, right? So our first definition is going to be free fall. Okay, there's not a lot of definitions in this section, so might as well learn this. So free fall, when the only force acting on an object as it falls is weight. Okay, so that's what free fall is. Okay, so with that said, okay, so for one directional motion, there's projectile motion, there are a set of equations. Okay, so we call these our equations of motion. Okay, and basically we use these whenever there is constant acceleration. Okay, in other words, when the acceleration is not changing. Okay, so for our equations of motion, these are the equations that we will see coming up pretty much all the time. We're going to use basically every single one of them. So let's get them down. There are 4 of them. Okay, so the first one, okay, we can say S is our, okay, so let's actually just define these things. Okay, so you're going to see a number of symbols. So you're going to see U, V, A, T, S. Okay, and the way I remember this is by that, UVATs. I just call them UVATs, and that way I can remember what the symbols are, or how many there are. And U, okay, so U stands for our initial velocity. V is our final velocity. Okay, A is our acceleration. T is time, and S is displacement. Okay, so remember on Earth, our acceleration, so for Earth, the acceleration equals g, which is equal to 9.8 meters per second squared. Okay, and let's just put the units in here. You guys should know them, but velocity initial is going to be in meters per second. Again, meters per second. Acceleration is meters per second squared. Time is in seconds, and displacement is in meters. So everything is in our normal SI units. Okay, so now let's get into our equations. Okay, so these are on your formula sheet, but they're not too difficult to remember, and once you use them a lot, you'll start remembering them. Okay, so let's start with our first equation is S equals UT plus a half AT squared. Okay, the second equation is V equals U plus G, or let's say AT. The third equation is V squared equals U squared plus 2AS. And the last equation, okay, so these are the 4 governing equations. S equals U plus V divided by 2 times T. Okay, let me just put the time sign in there. Okay, so this is how I write them out, right, here with my UVAT, but it can also be written, sometimes U can also be written as V initial, and this can be written as V final. So don't get too thrown off by different symbols. As long as you know what these equations are, you'll be fine. Okay, so when we're using these equations, we need to define a direction. Okay, because remember, 3 of these 4 things are vectors, right? So let's see, we have velocity is a vector, final velocity vector, again, acceleration is a vector, time is a scalar, but displacement is a vector. Okay, so when we're dealing with vectors, it's important to define a direction. So that's something we always have to do with any problem. Okay, and okay, so the way you define them is you either say, let's say we have something moving upwards, then we say up is positive, or we can say down is positive, or we can say, what's it, left is positive, we can say right is positive. Okay, and conversely, if up is positive, then down has to be negative, up has to be negative, and left has to be negative. Okay, so and the way we do this is we usually, it doesn't matter if you decide up is positive and you take and you end up with minus answers. It just gives you a direction and just makes sure that everything adds up in the end. So it's just important to, when we're doing these questions, to define directions, and that's something you'll do upfront all the time. But we'll see that when we start getting into some questions. Okay, and then again, when we're dealing with the Earth, okay, we usually take down as being positive. Okay, and the reason why we do that is because acceleration on Earth is always acting down, right? Acceleration always acts down on Earth, so it just makes sense, because then we can say our acceleration equals 9,8 meters per second squared down, and that just sometimes makes things easier. But if you decide that you want to pick up as positive, there's nothing wrong with that. You'll just end up with some minus values, answers at the end. Okay, so with that said, let's go into some questions, or a little more theory and then some questions. Okay, but yeah, I hope you guys were able to follow. If you want, just write these equations down, because we'll be using them throughout this video. I'm going to try to keep this video short, maybe 15 to 20 minutes, and have a second video because this section is quite long. Okay, so the first scenario, let's say, that we're going to tackle is dropping objects, or dropped objects thrown down. Okay, oh sorry, let me just not, let's say, okay, so the first scenario we're going to do is objects being dropped. Okay, or we can say objects being thrown down. Okay, these two fall in basically together. Okay, so when we see a question where we see this situation, right, where we see the word drop. Okay, so drop has some implications. Okay, basically it can be dropped, or we can say, let's see, some keywords that always come up is dropped, or released, or falls. Okay, if we see these words, what does it mean? Okay, so if you drop something, basically it means your initial velocity equals 0. So the object is initially at rest. Okay, and if we're on Earth, it also implies that acceleration equals gravity. Okay, so let's go into an example. Okay, I'm going to do examples in a different color. Let's see what colors would be interesting. Let's go with purple. Okay, so I'm going to do examples in purple and everything else in black, basically, or different colors. Okay, so let's go with example 1. Okay, so example 1. So a brick is dropped from a building and hits the floor 250 meters below. Okay, so that's just the outline of the question. So we want to determine let's say, how long does it take the stone to hit the floor. Okay, so initially, okay, so let's do the answers in a different color. I don't know, let's go with green or orange. Okay, let's go with orange. Okay, so let's pick up some things. Okay, so we have the word dropped. Okay, so we already know that our acceleration equals gravity and our initial velocity is equal to 0, just from that. Okay, we've been given S, which is 200 meters, and we're looking for how long. Okay, so how long means time, right? Okay, so I'm going to start off again. I am going to start off by setting up my UVATs. Okay, you don't have to do this, but it just makes life a bit easier if you know what information you have been given. Okay, and I'm going to take downwards as being positive. So I know my initial is 0. My final is an unknown. My acceleration is 9,8 and it's down, so it's positive. My time is the unknown, which I am looking for. And my displacement is going to be 250 meters. Okay, now I just need to go find an equation that will help me calculate the time. Okay, so I've got U, A, and S. So let's see. I've got U, A, and S, and I want to figure out T. Okay, so this first equation works for me. So I'm going to pick that. There are times where more than one equation may work, and you can pick either one. They should give the same answer. Okay, so let's go. S equals UT plus a half AT squared. So S is 200. U was equal to 0. So that entire thing becomes 0. Plus a half. Acceleration was 9,8. Sorry, this is 250. Acceleration was 9,8 and T squared. Okay, so T squared, there's only one unknown here, T squared, so I can say T squared equals 250 divided by 0.5 times 9.8. Okay, let me just write it out for you guys. Okay, so that comes out as 51,02. Okay, but we want T, so I'm going to square root both sides. So T comes out as the square root of that is equal to 7,14 seconds. Okay, so we get T, and that's the end of that. Something like this probably worth 3 marks maybe in an exam. Not too sure, but yeah. Okay, so obviously the next question, we've already calculated T, 7,14. So the next question is going to be what is the final velocity when it hits the floor. Okay, I'm not going to write that out because it's pretty obvious. Okay, so I'm going to use my same UVAT because basically I've got them right here. So nothing's changed, so I'm going to use the same UVAT, but now I have to go look for another equation. So I'm looking for V and I've got everything else. So I'm just going to go look for a nice easy equation. Because I calculated T, I'm going to try avoid using T. Just in case I made a mistake in the previous question, I'm going to try avoid. But sometimes you can't avoid using T, but in this case, I think I will get away with it. So let's see for an equation. Okay, this equation right here doesn't have T. It's the only equation without T, so that works for me. Okay, so the equation was V squared equals U squared plus 2AS. Okay, so again, V squared equals 0 squared plus 2 times acceleration times our displacement, which was 250. Okay, so V squared comes out as being, let's see, 4,900. So V, I'm going to square root both sides, and I am left with 70 meters per second. Okay, now my V came out positive, right? So that means my final velocity was whatever direction I chose as being positive, and I chose downwards as being positive, so my velocity is going to be down. Remember, velocity is a vector, and therefore we have to treat it with a magnitude and a direction. Okay, so in this section, you're going to come across a lot of graphs. So the next one is going to say, sketch the, let's see, VT graph, so the velocity time graph and displacement time graph. Okay, so the velocity time graph. So let's think about what this will look like. So always start off with your 0 point, and then the axes. So you have velocity in meters per second, and you have time in seconds. Okay, sometimes you should give a heading. I'm not going to in this case, but you can. Okay, so once we do this, okay, so let's understand what's actually happening. So we've dropped a brick, right? And we know it has constant acceleration. So we know the gradient is going to remain the same from our theory before that. And we know that it starts at 0, right? We know it starts at 0. And we know that at a time of 7,14, it has a velocity of 70 meters per second. Okay, so basically I can just join these 2 points because the gradient is equal to my acceleration, which is equal to g, which is a constant. Okay, so that's that. Okay, you can actually leave this stuff out. That was just to explain for you guys. Okay, now my next question is going to be my displacement in meters times time in seconds graph. Okay, so we know the displacement initially we're taking the top as a reference point. So initially it started out at 0, right? And then it ends up at 7,14 seconds. It ends up 250 meters away. Okay, but remember the velocity is constantly changing and the velocity is increasing, right? So initially it's moving a little, or it's the change in displacement is a little initially. Okay, this is where we need to end up basically. I need to get my graph there at the end. So initially it's starting off slowly, it's moving slowly, and then the velocity increases, right? So this is what our graph is going to look like. Our velocity increases, so we have a positive gradient. Okay, so we have a positive gradient and we have it increasing, so it's getting steeper. Okay, because it's getting faster and faster, so it's getting we're getting more distance on it. Okay. Okay, so let's see what the time is. Okay, I'm on 17 minutes, so I'm just going to stop it here, and then I'm going to have to break these videos down into smaller brackets. Okay, so thanks for watching, guys. I hope you guys found this useful. In the next video, we will go over throwing objects up and down. So yeah, thanks for watching, guys, and cheers.